The number of factors of 1800 that are multiples of 6. Start by prime factorizing. 1800 is 18 into 100, which is 2 into 3 square into 2 square into 5 square, which is 2 cube into 3 square into 5 square. Any factor of this number has to be of the form 2 power a into 3 power b into 5 power c. It cannot have a 7, 11, any of those numbers. If there are no conditions, this multiple of 6 were not there, then a can take value 0, 1, 2, 3, b can take value 0, 1, 2, c can take value 0, 1, 2, number of factors 4 into 3 into 3, whatever that is. Now this number, any factor of this has to be a multiple of 6. So factor should have a 2 and a 3, or quite simply, here a can take values 1, 2 or 3, b can take values 1 or 2, c can take values 0, 1 or 2. There has to be at least 1, 2 and at least 1, 3 in the factor. So a cannot be 0, then the number will be an odd number, cannot be a multiple of 6. B cannot be 0, it will not be a multiple of 3, cannot be a multiple of 6. Or a can take 3 values, b can take 2, c can take 3, 18 factors. There are 18 factors of 1800 that are multiples of 6. Other way of doing it, take 1800 divided by 6, find number of factors of this number we have to. The number of real solutions of the equation x square minus 15x plus 55 whole power x square minus 5x plus 6 equal to 0 is equal to 1. Beautiful ways of thinking about it. Suppose I have a power b is equal to 1. When can this happen? First of all, 1 power anything is 1. This is one way. Anything power 0 is 1. This is one way. 1 power 3 is 0, 1 power minus 2 is 0, 1 power minus 11 is 0, 1 power 3 is 1, 1 power minus 12 is 1, 1 power 11 is 1, 1 power root 3 is 1. 3 power 0 is 0, 15 power 0 is 0, 23 power 0 is 0, minus 23 power 0 is also 0. Minus 23 whole power 0 is also 0. Brilliant. Apart from this, there's one another way of doing this. Minus 1 power an even integer is 1. Minus 1 whole square is 1. Minus 1 whole cube is 1. Sorry, whole power 4 is 1. Minus 1 power minus 26 is 1. Right? So, for solving this equation, you have to solve 3 categories. Put the base is equal to 1. Solve for that. Put the power is equal to 0. Solve for that. Put the base is equal to minus 1. Solve for that. Find x. Plug that in the power. Verify if it's an even number. Okay. We're going to do all 3. Let's go step by step. Let's put x square minus 15x plus 55 equal to 1. X square minus 5x plus 6 is equal to 0. The simple ones. Let's solve this. So x square minus 15x plus 54 is equal to 0. X minus 9 into x minus 6 is equal to 0. X is 9 or x is 6. If x were 9 or 6, then that part, the x square minus 15x plus 55 part will go to 1, which is very nice, very comfortable. This side, we have x minus 2 into x minus 3 is equal to 0. So x is 2 or 3. If x were 2 or 3, then the power would go to 0. If x were 2 or 3, this is something power 0, 1, that will work. If x were 6 or 9, then it is 1 power something, that is 1, that will also work. So 1, 2, 3, 4, 4 values of x are in the bag. Now what do we do? This is all very interesting. Let's say x square minus 15x plus 55 is equal to minus 1. X square minus 15x plus 56 is equal to 0. X minus 7 into x minus 8 is equal to 0. X is 7 or 8. If x were 7 or 8, then that base becomes minus 1. Now comes the interesting part. When x is 7 or 8, what happens to the power? X minus 2 into x minus 3. Let's do 7 minus 2 into 7 minus 3. 5 into 4, 20, even number. That works. If we put 8 minus 2 into 8 minus 3, 6 into 5, 30, even number. whenever x is an integer, x minus 2 into x minus 3 is product of two consecutive integers. One even, one odd, product will be even. I don't have to really do this, but hey, even if I've done this works. So when x is 7 or 8, we'll be looking at minus 1 power 20 and minus 1 whole power 30. Both are equal to 1. So 6 and 9 will work, 2 or 3 will work, 7, 8 will work. We have 6 different values x can take. Beautiful question. In a group of 150 students, 52 like tea, 48 like juice, and 62 like coffee. The students in the group likes at least one among tea, juice, and coffee, and the maximum number of students that like more than one drink. It's a classic set theory question. So this is tea, 52, juice, 48, coffee, 62. Each student likes at least one among this. So outside is 0. Total is 150. Nice, brilliant. Now this famous equation, which is A union B union C, is number of units in elements in A plus number of elements in B, and then minus number of elements in A intersection B, B intersection C, C intersection A, plus number of elements in A intersection B intersection C. I technically have to write it down like number of elements here, but we all know what we're talking about. Right? So number of elements in A plus number of elements in B plus number of elements in C minus this minus this minus. Why do we do this? Because when we add this to this to this, these parts get double counted. Let us subtract that. This part gets triple counted. Let us subtract that twice. So when you subtract this, we eliminate the double count, but the A intersection B intersection C gets eliminated completely. So we add it back. Double count removed, double count removed, double count removed. When we are doing that process, the thing that got counted thrice got added thrice, subtracted thrice. It has gone from the system completely. I don't want it to go from the system. Therefore, I do this. And that's the idea behind it. I'm not going to do it by this method. I'm going to do it by a slightly different method with the same base units. The diagram is the same. So we have T, which is 52. We have juice, that is 48. Coffee, that is 62. Right. Overall, it is 150. Outside is 0. We want to find the maximum number of people that like more than one drink. And so I want to call this as x1, x2, x3, this is y. Right. I want to further say that x1 plus x2 plus x3, let me call it as x. And so number of people who drink tea, number of people who drink juice, number of people who drink coffee, they are there. Total number of people that drink at least one of the three, that is there. Exactly 2 of the 3, x1, x2, x3, all 3, that is y. So if I think about this 150, I can think of 150 as 52 plus 48 plus 62 minus, when I do 52 plus 48 plus 62, I double count x1, x2, x3, I say minus of x1 plus x2 plus x3 minus 2y. I triple count this y, I subtract that twice over. Nice. Or 52 plus 48 is 100, 100 plus 62 is 162, 150 equals 162 minus x minus 2y. 2y plus x is equal to 12. Brilliant. We have 2y plus x equal to 12. Now we want to find the maximum number of students that like more than one drink. That is x1 plus x2 plus x3 plus y. x1, x2, x3 are 2 drinks exactly. y is all 3 drinks. Or we want to find x plus y maximum. 2y plus x is 12. We want to find x plus y maximum. If you put x as 0, y will be 6. X plus y is 6. If we keep increasing x, y will decrease. But y has 2y in it. 2y plus x is 12. So if I increase x by 2, y should decrease by 1. Or if 2y plus x is 12, I want to maximize x plus y. I should tank y. I should have as many x as possible. So if I put x equal to 12, y equal to 0, then x plus y maximum is 12. X plus 2y is 12. If x cannot be 14, y cannot be negative. X cannot be 13, y cannot be negative. If x were 10, y will become 1. 2 plus 10 is 12. This will become 11. It will reduce. Higher x is, better it is for us. Maximum possible x that can come is x is 12. And so, very interesting thing. Whenever we learn set theory, we learn this. Think about learning this also. Same equation, slightly manipulated, slightly differently. Let ABC be a triangle right angled at B with AB is equal to BC equal to 18. Okay. AB is equal to BC equal to 18. Isosceles right angle triangle. 90, 45, 45. The area of the largest rectangle that can be inscribed in this triangle and has B as one of the vertices. So looking at a rectangle like this. Let's say B, P, Q, R. Nice, brilliant. So let's say this has sides L and B. This will be L, this will be B. This is 18 minus L. This is 18 minus B. Okay. And what do we want to do? We want to maximize the area. Area is LB. We want to find LB max. My instinct straight away is telling me go towards a symmetric diagram, find a way to draw a beautiful square. That's our answer. In under extreme scenarios of time pressure, I would punt and say put as a square 9 and 981, go for it. Now I cannot do that, so I'm going to hold on to my instinct and then come back and solve this. So L 18 minus L, B 18 minus B. This triangle APQ is similar to QRC, or 18 minus B by L is B by 18 minus L, or 324 minus 18B minus 18L plus LB is equal to LB, or 18 times L plus B is 324, or L plus B is 18. Kind of understandable. This should be equal to this, this should be equal to this. 18 minus B is L, B is 18 minus L. Right? So that's what is being conveyed here. With these two triangles have to be similar. It's anyway an isosceles right angle triangle. So I could have just taken this to be 45 degrees, B equal to 18 minus L, done. I need not have done all this. That's all right. All right. So L plus B is 18. What is the maximum value of LB? Sum of two numbers, positive numbers, is 18. When will the product be maximum? When the numbers are equal. 9 plus 9 equal to 18. Maximum value of product is 9 into 9, 81. The more algebraic way of doing it is L plus B by 2 is greater than or equal to square root of LB. L plus B by 2 is 9 greater than or equal to square root of LB. LB is not equal to 81. Maximum possible area is 81 square units. A fruit seller has oranges, apples and bananas in the ratio oranges, apples and bananas in the ratio 3:6:7. If the number of oranges is the multiple of both 5 and 6, then the minimum number of fruits. Oranges should be at least at the form 30k. Should be a multiple of 5 and 6, so it should be a multiple of 30. I want the least possible thing. So this is 30k, this is 60k, this is 70k. 30, lucky enough, is already a multiple of 3. I don't have to worry about incorporating this 3 into the equation. Or the total is 100 60k. 30 plus 70 is 100, 100 plus 60 is 160k. K cannot be a fraction. The minimum value k can take is 1. Minimum number of fruits a seller has is 160. 30 oranges, 60 apples and 70 banana. I cannot believe my eyes. I have to make sure that this question is as simple as that. Hello folks, those of you who are thinking about IPMAT, the integrated 5-year course, you've got to think about it seriously. Parents who are listening in, you have to plan for this. After 12th standard board exams get over, there are a ton of exams. This IPMAT integrated course is a brilliant course. It's a 5-year course. Anyone who's interested in MBA, anyone who's saying, look, I don't want to do the mainstream thing, but I want to do something compellingly good, you must take this as part of your structure, as part of your set of options available. The number of seats is not too high, so you cannot say this is my only option, but you have to say, hey, I'm giving this a go. The exams to write, very clearly, these three. On IPMAT is on April 26th. IPMAT for Rohtak is on May 5th. Indore is for May 12th. This is the simplest exam. This is the toughest exam. So, be a nice gradation. You have to prepare for it. It's not a bleeding obvious exam that you can just go and wing it. There's also data interpretation, logical reasoning section. We guys have a course for it, which covers a bunch of live sessions. We'll be doing 6 hours of live sessions for 3.5 weeks. That's a run up to the exam. Bunch of mocks that we will administer to them and discuss and help and mentor and plan all of that with detailed video solutions. Whatever we do, we'll have detailed video solution for the previous year papers. We'll discuss them also in great detail. We'll come up with a good strategy for them to attack this. And the young kids, will do our best to help them take this exam, help the students take this exam. All of this included. The course begins the kind of almost immediately after the board exam ends. So it's on March 31st. So details of the course, how to sign up, when to pay, all of those are available in the description. Check that out, sign up and have fun. Best wishes. The number of pairs x comma y of integers satisfying the inequality. Modulus of x minus 5 plus modulus of y minus 5 less than or equal to 6. First of all, I'm going to put x minus 5 equal to p, y minus 5 equal to q. Solve for mod p plus mod q less than or equal to 6. Simpler. For every value of p, I'll get a corresponding value of x. Every value of q, I'll get a corresponding value of y. So for every p comma q, there is only one, exactly one set of x comma y. If I solve for this and find number of solutions of p comma q, I'll get the same thing for x comma y. What can this be? Mod p plus mod q less than or equal to 6. Both are positive, both are integers. So I can say, hey, mod p, let it be 6. In this case, mod q will be 0. Mod p, let it be 5. Mod q will be 0 or 1. 4, 0, 1, 2, 3, 0, 1, 2, 3, 2, 0, 1, 2, 3, 4, 1, 0, 1, 2, 3, 4, 5. This is 0. This can be 0 to 6. Nice. Mod p, when it will be 6 plus or minus 6, p is plus or minus 6. Q has to be 0. 2 solutions here. I want to think about number of values very differently. Plus or minus 6, 0, 2 solutions. 0, 1, minus 1, 3 values. Plus or minus 5, 2 values. 2 into 3, 6. Plus or minus 4, here 2, 4, 5, 4, 2 into 5, 10, 2 into 7, 14, 2 into 9, 18, 2 into 11, 22, 1 into 7, 7. 0 to 6 is 1 into 7, 7. Only one value for P, 7 values for Q. Add all this up, 2 plus 6, 8, 18, 32, 50, 8, 18, 32, 50, 72, 79. Let me just think about this. You can take values from 0 to 6, not 7 values. This is 13 values. 35 plus 32, 67, 77 plus 8, 85 values. Sorry, I put only 7 there. 13 values, 0 to 6, minus 1 to minus 6. Not 7 values, 13 values. 0 to 6, 1, 2, 3, 4, 5, 6, 0, 7 values. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. 7 more values, 6 more values, 7 plus 6, 13 values. The other way of thinking about it, mod P plus mod Q less than or equal to 6. You can think of it visually and say minus 6, 0, 6, 0, 0, minus 6, 0, 6, 0, 0, 6, 0, minus 6. All integer values, integer pairs sitting inside here. So we can say when this is 0, all of these values inside. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let me just move this. Minus 1, minus 2, minus 3, minus 4, minus 5. 1, 2, 3, 4, 5. And then 6 and minus 6 also. And this goes to 1. Then there will be fewer values, fewer values, fewer values. So it will go all the way up here, all the way down here. Count all of this. This is P comma Q. What is mod x minus 5 plus mod y minus 5? This whole diagram shifted out to the point 5 comma 5. So we'll have a diagram. This diagram moved like this. So it will probably not going to draw the best diagram, but you can imagine it like this. Same thing shifted out like that. Right? So we can simplify the question and then get to the answer. 85 different pairs are possible. The price of chocolate increased by X% and then reduced by X%. The new price is 96.76%. So whatever the price is, plus 1 plus X by 100 into 1 minus X by 100 is equal to 0.9676 X. Not X, P. So, or 1 plus X by 100, I don't like that. 1 plus Y into 1 minus Y. Or Y square is 1 minus 0.9676. I really like this number 9676. You subtract that from 1, you get Y square 0.0324. Or Y is 0.18. Or X is 18. 18%, you increase it by 18%, decrease it by 18%, we'll get to this number. And 0.0324 is 18 square is 324, I know that. But this number is a nice, convenient number. 0.0324 is 0.18 whole square, which means Y is 0.18, X is 18. Every time I have an X by 100, I make it a Y. My brain thinks better in fractions than in decimals or percentages like that. 18 by 100 is annoying. 0.18 is okay. Y is better. Fine. So I'll call it Y and then deal with that from there. Let f and g be two functions defined by f of x equal to modulus of x plus mod x, g of x equal to 1 by x for x not equal to 0. What is if f of a plus g of f of a is 13 by 6 for some real a, then the maximum possible value of f of g of a. So, f of a plus g of f of a equal to 13 by 6. F of x is modulus of x plus mod x. When x is positive, x plus mod x will be twice of that. So modulus of 2 times x. When x is negative, x plus mod x will go to 0. F of x will be 0. Any negative x, f of x is 0. I like that. I want to keep that in my head. So g of f of x is not even defined when x is negative, because f of x will go to 0. G of 0 will become 1 by 0. Not possible. And so this question is kind of telling us, think of this whole thing for a positive, a being positive. And g of f of a plus g of f of a is 13 by 6, or f of a plus 1 by f of a is 13 by 6, or y plus 1 by y is 13 by 6. Y square plus 1 is 13 by 6 times y. 6y square minus 13y plus 6 equal to 0. 6y square minus 9y minus 4y plus 6 is equal to 0. 6y into 3y into 2y minus 3 minus 2 into 2y minus 3 is equal to 0. 3y minus 2 into 2y minus 3 is 0, or y is 2 by 3 or 3 by 2. Whenever you are solving for this, the roots will be reciprocals of each other. If y equal to k works, y equal to 1 by k will work. So something you just keep in mind. So 3 by 2 or 2 by 3. F of a is 3 by 2 or 2 by 3. So f of a, which is modulus of a plus mod a, is equal to 2 by 3 or 3 by 2. We know that when a is negative, f of a goes to 0. This is not negative, it doesn't go to 0. Or 2 mod a, or 2a is 2 by 3 or 3 by 2. Or a is 1 by 3 or 3 by 4. Nice. The maximum possible value of f of g of a. So a is 1 by 3 or 3 by 4. G of a is 3 or 4 by 3. 1 by x. F of g of a, 3 plus mod 3 whole modulus 6 or 8 by 3. The maximum possible value of f of g of a is 6, because 6 is more than 8 by 3. That's it. Four par log x to the base 2 minus 4x plus 9 par log y to the base 3 minus 16y plus 68 is equal to 0. Very nice. 4 par log is 2 square par log x to the base 2 minus 4x plus 9 par log y to the base 3. I'm going to write 9 as 3 square minus 16y plus 68 is equal to 0. This is 2 log to the base 2 of x square. This is 3 log to the base 3 of y square. 3 par log of y square to the base 3 is y square. So a par log b to the base a is b. We take log on both sides. Log b to the base a log a is log b. Log b to the base a is log b by log a. That works. So the very definition of log, a par log b to the base a is b. So this, if you plug here, this expression becomes this idea. Hang on to that. Super powerful, very useful. You need to keep that in our head. This expression, which has become this, will now become x square minus 4x plus y square minus 16y plus 68 equal to 0. The moment I see this delightful equation, I'm thinking, hey, completion of squares, here I come. So we say, hey, x square minus 4x plus something plus y square minus 16y plus something equals this something plus something minus 68. Why did I put minus 68? 68 I'm taking that side. Why did I put plus something because I want to complete the square. X square minus 4x plus 4, y square minus 16y plus 64, y 64, because this will now become x minus 2 whole square plus y minus 8 whole square is equal to 68 minus 68, 0. I was hoping it will be 0, because then it gives us a beautiful unique solution. This tells us x is 2, y is 8, nothing else is possible. We want to find y minus x, 8 minus 2, 6. Done. Person A borrows 4,000 from another person B for a duration of 4 years. He borrows a portion of it at 3% simple interest per annum, while the rest at 4% from simple interest per annum. 4,000 rupees at 3% for 4 years at 4% for 4 years. B gets 520 rupees as total interest when the amount A borrowed at 3%. It's freebie. And you can do it algebraically. Say this is X, this is 4,000 minus X. So X into 3% into 4 years plus 4,000 minus X into 4% into 4 years is 520. Solve for X, we're through. So this is 0.12X plus 4,000 into 4%. This is into 4. 4 into 4 into 4 is 64 plus 640 minus 0.16x equals 520. Bring that this side. 640 minus 120 is 520 is 120 equals 0.04x. X is 3000. 120 by 0.04, 3000. And just brute forcing it, writing an equation and solving it. Nothing in this. The other way of thinking about it is 520 is the interest. That is 4,000 as a principal into rate of interest into 4 years. Find that rate of interest, which is 52 by 400 into 4. This is 13. 13 by 400 is 3.25 by 100. Or rate of interest is 3.25. Or you're mixing 3% and 4% to get 3.25%. You should have mixed them in the ratio 0.75 is to 0.25 or 3 is to 1. This should have been at 3,000. That should be 1,000. The mixtures and allegations method both work. Nice and simple question. Nothing here. Not a great interesting question. The number of triangles with integer sides with perimeter 15 is 3 sides A, B, C. I'm going to assume A less than or equal to B less than or equal to C. A plus B plus C is equal to 15. A plus B greater than C. That's it. Sum of the 3 sides is 15. To assume them in some order. Ascending order A less than or equal to B less than or equal to C. Non-descending order A plus B greater than C. Sum of any 2 sides has to be greater than the third side. Sum of the 2 shorter sides has to be greater than the third side. If I put A is 1, 13 doesn't work. 1, 2 something doesn't work. 1 plus 2 should be more than the remaining. Only possibility is 177. And 168 doesn't work. 1 plus 6 is less than 8. When A plus B is greater than C, or C is less than or equal to 7. If C were 8, A plus B would be 7. Not possible. C is less than or equal to 7. With 1, A being 1, there's only one triangle possible. Let's put A as 2. These two add up to 13. 5 plus 8 is 13. Doesn't work. It cannot be 8. 2, 6, 7. We put this as 3. These two add up to 12. So this can be maximum 7, 3, 5, 7, 3, 6, 6. Let's go to 4. These two add up to 11. I could have 4, 4, 7, 4, 5, 6. Let's go to 5. 5, 5, 5. 1, 2, 3, 4, 5, 6, 7. 7 possible triangles. Perimeter is one equation. Sum of 2 sides greater than the third one is one equation. These are the 2 ideas from geometry. This is a simple way of structuring it so that you can go from one and roll the other. Put A equal to 1, 2, 3, 4, 5. A less than or equal to B less than or equal to C. A cannot be more than 5. 6 plus 6 plus 6 is 18. So perimeter is 15. The maximum value A can take is 5. A can take values 1, 2, 3, 4, 5. For each value of A, slowly think about B and C. The following table shows the number of employees and their median age in 8 companies located in a district. Median age is the middle age, middle point, and you arrange them in ascending order. An odd number of terms, median is very easy to find. Even number of terms is a pain. Okay. Employee company A, 32 employees are there in company A, A1, A2, A3 till A32, assumed in ascending order. A1 less than or equal to A2, less than or equal to A3, less than or equal to A4, all the way till A32. Median age is 24. Even number of terms, 2 middle terms. So A16 plus A17 by 2 is 24. Here B has 28 employees. B14 plus B15 by 2 is equal to 30. And so on. I'm not going to write all of this. C, 43, odd number. 44 by 2 is 22. C, 22 is 39. Number of employees, median age. I'm not going to write all of this down. I don't need to. I'll figure it out. Okay. It is known that the age of all employees are integers. A1, A2, A3, A4 till A32, B1, B2 till B28. All of these are integers. It is known that age of every employee in A is strictly less than the age of every employee in B. Oh, nice. Age of every employee in B is strictly less than every employee in C, and so on till age of every employee in G is strictly less than age of every employee in H. Arrange each of them in ascending order. I know for sure that A1 less than or equal to A2 less than or equal to A3 all the way till A32. Likewise, B1 less than or equal to B2 less than or equal to B3 all the way till B28. I also know that A32 is less than B1. B28 is less than C1. C43 is less than D1, and so on. The oldest employee in B is younger than the youngest employee in C. Every employee in A is strictly less than the age of every employee in B, and so on. So within A, there is a non-descending order. Within B, there is a non-descending order. Within C, there is a non-descending order. But group A, every employee is younger than every employee of B, every employee of C, every employee of D. So we kind of drew a graph for this, hypothetically. Then ages of employee A, then the next block would be B, next block would be C, and so on for that. And we can solve for anything in it. Right? The highest possible age of an employee of company A is highest possible age of an employee of company A. Median is 24. Give or 16 of them are greater than or equal to 24. 16 of them are less than or equal to 24. Remember, all of them could be 24. Right? The highest possible age of an employee of company A. We know A32 is less than B1. B1 is the youngest employee in B. B median age is 30. I could have a scenario where all employees in B are 30, 30, 30, 30, 30, 30, all of them are 30. That will be the best case scenario for the youngest employee in B being the oldest possible age. 30, 30, 30, 30, 30, all 28 being 30, or 30, 30, 30, 30 till the 15th employee, 16 to 28 being 31, 32, 33 till maybe including 35, 36 till 37 is possible. Right? But the youngest employee of B, his maximum possible age is 30. B1 max is 30, or A32 max is 29. And this median age minus 1 is the oldest employee in A can be, or the highest possible age of an employee of company A is 29. The median age of an employee across the 8 companies is my first instinct was, we can't find that. Right? Then I said, look, this is a question, there should be something interesting in it. Let's find it. Let's add all of this. Find the total number of employees. 10, 13, 22, 27, 36, 39, 45, 5, 4, 7, 9, 13, 16, 19, 21, 23, 24. 245 employees totally. 245 plus 1 is 246, by 2 is 23. So I call this whole thing as one M and call the ages as M1, M2, M3, M4 till M245. Then that median is M123. I arrange all of these in non-descending order, I cannot say ascending order strictly because it would be equal. It will be this. When I'm arranging them in non-descending order, the way I'll go about it is A1, A2 till A32, and then B1, B2 till B28, C1, C2 till C43, D1, D2 till D39, E1, E2 till E35, F1, F2 till F29, and so on. Right? If I arrange in that sequence, what will be the 123rd element? The first 32 elements will be in A. The next 28 will go to B. So when the last element of B is counted, we are at 60. And then 43 from C will come, we are at 103. Then 39 will come, we are at 142. But we want the 123rd element. So our median fellow is from company D. 104 to 142 is from company D. Exactly what element will be? 103 to 142, 104, 105, 106, 107, 108, 109, 110. We keep on going like that. Then M123 is D something. This is D20 because M104 is D1, M105 is D2, M106 is D3, M123 is D20. 103 plus this number is this number. The 20th element in D will be M123. Now, how are we supposed to find the 20th element in D? Because D, median is 45, but how do we know some item in the middle? So, weird question, how can we find a unique answer? Turns out we can, because D20 is the median of D. Remember, D has 39 elements. So, if you think about it, if we have D1, D2, D3 all the way till D39, D20 will be bang in the middle. That is the median. 19 elements this side, 19 elements this side, 38 plus D20, 39 elements, perfectly bang in the middle. Or M123 is nothing but D20, which is median of employees in company D, which age is 45. And the numbers are very friendly. That is so happens that the overall median also happens to be the median of D, bang in between. Lucky, happy. In company F, the lowest possible sum of ages of all employees. Lowest possible sum of ages in company F. Median is 54. So 29 elements. So F15 is 54. Middle term is 54. I have F1, F2, F3 till F14, F16, F17, all the way till F29. 14 elements this side, 14 elements this side. The middle term is 54. I'm very happy. I want the total to be as low as possible. All these numbers are less than or equal to 54. All these numbers are more than or equal to 54. Nice, so far so good. Now I want the overall sum to be as low as possible. Every number to be as low as possible. Maybe I'll put this as 1, 1, 1, 1, 1, 1, 1, 1. That's not possible because E has median age is 49. Every employee in F is older than every employee in E. So the youngest possible employee in F has to be at least 50. When will that happen? When E's middle term is E18, 19 till E35, E1, E2 till E17. This age is 49. All of these fellows are 49. Maybe everybody is 49. Then F1 can be 50. Best possible scenario. Right? This side from F16 to F29, all of them are greater than or equal to 54. Remember, we want the total to be as low as possible. I'll not say they are greater than or equal to 54. I'll put all of them as equal to 54. This fellow is 50. All of these fellows are less than or equal to 54. Why less than or equal to 54? They all can be equal. I'll put all of these fellows to be 50. Or F can have a beautiful combination of 14 people who are 50 years old, 15 people who are 54 years old. This median condition can be satisfied. This median will be satisfied. Everything was the best case scenario. So the smallest possible sum of all the ages is 50 into 14 plus 54 into 15. 50 into 14 is 700. 54 into 15 is 810. 700 plus 810. 1510. Done. Through.